Okay. So good morning, everybody.
Right now I don't
Today,
have Wi-Fi.
huh?
Right now I don't have Wi-Fi.
You don't have Wi-Fi?
Not right now.
Okay.
Well, I
Well,
do, but I'm not home.
okay. Well, then, I'll keep that in mind as I'm seeing everyone else working on stuff. Um, good morning, guys. Today is February 22nd. Happy Monday. I mean, when is Mondays actually happy? But we can pretend. We can pretend. Um, it's happy because you're in my class now. So, um, so a couple of things before we get started. One, we have 16 days left before the end of this semester. So that means you have 16 days, that's including Saturday and Sunday. Um, so it doesn't give you that much time, guys. So some of you guys are not happy with your grades. So continue working. Remember, do your notebooks, those are worth a lot, and there aren't that many. Do all of the formative assessment ones. So if you're looking at your progress reports that I've sent you to you guys, right next to the title, it'll say formative assessment or assignment or participation or notes. So look for ones that say formative assessments or assignments. Um, or if you guys have been missing any of your tests or quizzes. Because some of you guys weren't here for the actual test and some of you guys weren't here for your quiz. So some of you guys are missing that. One other thing, look at this calendar of February. We're in the last week of February, which is crazy. It went by crazy fast. This is our last full week of learning something new. Next week, which will be March, we'll have 2 days of practice with what we've been learning this week. And then we'll end the week with our review for our finals. So absolutely make sure that next Thursday and Friday you're here because that will be your review for your final. And then our last week of school for this session, um, it's just Monday and Tuesday. We're going to take our final. It's going to be a 2-day test. It does take quite a bit of time because it is pretty long. It's like 18 questions. Um, so it's going to take us 2 days to do that. And then we don't actually see you guys on March 10th. That is a Wednesday. So the last day that we see you is the last day of the final. But like you guys had mentioned before, if you guys want to come during office hours on Wednesday of next week, no, 2 weeks from now, then we can all say our goodbyes on that day. Obviously, for the following year, if we, go into hybrid and all that stuff for next year, come and say hi to me. I mean, you'll have to say, hi, I'm this person from this period because I rarely see your guys' face. So I have no idea what most of you guys look like. So you'll have to come to CV High and say hi to me once we're actually on campus. Um, so I thought that last week's test was the actual final. No, no, last week's test was your first test. That's kind of like a midterm, and then you have a final. So that's like that. We have our final is always the final like week of school. Um, for today, we're going to be working in our notebook, and then you guys have a homework assignment, and do not leave until Ms. Gomez talks about this assignment. Some people last period were leaving before they were supposed to have left. So
Didn't even
um
survive.
yeah, so just chill and relax. Um if you guys would go to your Google Classroom, click on classwork, under week 8, go to week 8 notebook. Now, unlike last time where we were doing a lot of sorting activities, for the next 2 weeks, we're going to actually do bell works. Now, these bell works are to help you prepare for your final. Every bell work that you guys will see will be similar to a question that will be on your final. All right. So it's similar, not 100% exact. But if you guys can do these questions, you guys will be able to do your final. All right. Now, if there's something about these questions you don't know how to do, This is your opportunity to ask. All right. So as I'm going over these, first try it yourself, and I'll give you guys the length of a song. And then we'll go over this. So as I'm going over it, if you still don't understand, this is a time to ask, because this is when you guys can learn how to do it, because it'll be on your final. All right. So again, all of you guys should be in week 8 notebook. And we're on page 1, and it's going to be bell work, Monday, February 22nd. All right. I'm going to pause, not pause. I'm going to, where is my audio?
Let me resume recording. Hello.
You hear me?
We hear you.
Yeah, but it switched me off of my headphones.
Now it's back. Okay. All right. So let's get started. Again, you guys should be the ones to tell me what the answers are. Again, it's okay for us to get these wrong. I know you guys don't do very well with graphing for some of you guys. That's the reason why we're putting more of an emphasis on the graphing part for today's notes. And we're pretty much giving you guys all the extra work is so that you guys can focus on just the graphing. So looking at this function, can anyone tell me what the y-intercept would be? What's the y-intercept? 2. So I can either write it like this as 2, or I could have written it as a point and said 0, 2. So you have those 2 options. You don't have to write both, you just have to write one. What about the slope? What would my slope be?
2/3.
You combine these 2, but it's only one or the other.
Oh,
So if I use 2, then what would slope be?
3, -3.
It would be -3. Now, some of you guys wrote it like this and wrote it as a fraction and left it as -3/1, which this is fine since our idea is our final product is to graph it. So this is perfect to leave it as a fraction to help us out with the graph. So I can't figure out if it's increasing or decreasing or if it's linear or exponential. I mean, we kind of can, but I'm going to look at this first. And I'm going to start off with my y-intercepts. I'm going to start here at 0, 0, and I'm going to go up 1, 2. So I'm going to plot this point right here. Looking at our slope, this is negative, so it's telling me I need to go down. And then 1 to the right. So I'm going to go down 3, 1, 2, 3, and then 1 to the right. I can do that again. 1, 2, 3, 1 to the right. I can't do it one more time because I don't have space. But another thing that I could do is that I can switch the negative sign. And instead of 3 being a negative, it can be a positive. And then the 1 would be a -1. The reason why I do this, and I want you guys to practice that, is sometimes when we're graphing, we don't have enough space to go one way, so we have to go the other way. So I'm going to count 1, 2, 3, and then 1 to the left. This meant I needed to go up 3 and then left 1. And then from here, I can connect my dots. So I'm going to grab the line. So notice the directions that I took. I used the marker, the pen, to plot my points. And then I used the add a line to draw my line. And then I was able to change my color. Do I have to change colors? No, but I like purple. I mean, I like green better, but the green on here I don't like.
Yeah.
All right. Now, to help you guys out on understanding if it's increasing or decreasing, if you guys remember from like one of the first lessons that we saw that if we wrote the word slope, its direction helps us out to be able to tell if we're increasing or decreasing. So looking at this, are we increasing or are we decreasing? Is it an L or a D?
Decreasing.
Decreasing. We know that because the word slope is going down. We could have also looked at the negative right here in the front of slope, and we could have been able to tell that it was also negative from that. Now, looking at the equation, is this a linear or exponential function?
Linear.
I'm assuming you guys said linear.
Yeah, I think I heard that.
Hold on one sec. All right. Let me see. Alexis G. We're in week 8, and then we're in the week 8 notebook, and we're on page 1. We're just reviewing what we just did. All right. Looking at question 2. We can solve this, and I'm going to show you guys all the different steps, or at least you guys will do it together. What would be my first step in this equation? Can anyone tell me? Think PEMDAS.
Multiply the parentheses.
Multiply the parentheses. Another way of saying that is called a distributive property. So I'm going to abbreviate that with a D and a P. So distributive property. What that means is that we're going to multiply the 2 to everything inside of the parentheses. So 2 times x gives me a 2x. And then 2 times a negative 1 gives me a negative 1. Negative 2, just kidding. I don't like the way that the x looks. That's why I got confused. I'm like, do I want to redo that? Do I not? Yes, I do. And then everything else comes down. Can anyone tell me what the next step would be?
Combine the x. So like you would have to
Yeah.
subtract x from 2x.
Exactly. So I have like terms on the same side. So I have a 2x and I have a negative x. I can combine them by subtracting them. So 2 minus 1, 2 minus 1 gives me a 1x. And then I can't do anything with this negative 2 because it doesn't have an x. So I'm just going to bring those down. This was to combine like terms. So I'm showing you the steps. You're not going to have to do those steps on your final. You'll just have to give me the answer, but it's also good for you guys to see what the steps are to help you guys out. What would be my next step, guys?
Cancel the 2 out. So you
How?
have to add 2.
Add
Add
2.
2 and then add
So
2.
I see a negative 2. What's the opposite of a negative 2? That would be a positive 2. So I'm going to add 2 to both sides. And add 2 again. So the 2's go away. I'm left with just the x. I don't have to put this 1 in front of it, so I'm just going to leave it. It's invisible. Equals 16 plus 2. 16 plus 2 is 18. Oh, isn't that a super awesome 8? I love that 8. It looks like garbage.
Oh,
Oh, okay. I almost had that one good, except for this little corner right here. And then that's it, guys. All right, so every day, except for obviously Wednesday, we're gonna do a bell work. Again, these questions will be on the final. So if you guys have any questions, please let us know. So right now, if you guys have any questions, you don't understand how we got something, let us know in chat or unmute yourself. Or if this so far is easy, then that's really good. All
Mhm.
right. But I'm going to stop sharing. What happened to the 1x? Okay, so what happened to the 1x is it's technically here still. All right, only because it's a 1, it's invisible. I don't have to deal with it. However, if this instead would have been like a 2, and this would have been a 2, then I would have had to divide both of these by 2 and get rid of the number in front of the x. So then that, that would get rid of it. And then I would end up with what, 9? X equals 9. So that's the reason why the 1 went away, is because it's still there, it's just with the x. The next question I got was what happened to the 2x? I'm assuming you're talking about this 2x. And I combined it, I subtracted it by this. And remember, there's an invisible 1 right here. So 2 minus 1 gives me 1x. Both very good questions.
Mhm.
Any other questions before we move on? Okay, so I'm going to give up power
To me.
to Ms. Gomez.
Okay, boys and girls. So we are staying on your week 8 notebook. So don't close that. We still need that. We are going to be moving on to slide 2. So see, I used green, but it's not a nice green. Okay, you want to be on slide 2. This is going to be our day 2 of solving systems by graphing. Again, for those of you that are not able to follow along with us because of your internet issues, that's okay. We will have this recorded period on Google Classroom, but you can also go to this little section here, where it says day 2 notes. All you have to do is click on them and it takes you to the Google Slides of today's presentation. So if you go through the slides, it gives you the answers for where each of those pieces should be. But I'll close that up. And as well as using those Google Slides, I'll let you take screenshots at the end of each page. And then that should help you drag the correct pieces to the correct spots. But other than that, this is really day 2 of solving systems by graphing. That might sound new to you, but on Friday when we were working through the seating chart with that crazy math teacher that did equations and graphs, and we were looking at the students' characteristics and where they would be sitting based on their characteristics, that was technically our day 1 of systems of equations. So you were working with systems, you just didn't quite know it yet. But today we'll dive in a little deeper and find out more about systems of equations. So give me a thumbs up if everybody is here on slide 2. I'll go ahead and get started with your presentation and your notes. Give me a clap if you need more time to get to day 2 of your week 8 notebook. Okay, we're ready to go. Okay, so this is system of equations by graphing. So when you have systems of equations, okay, the word system just means more than one equation or a pair, or it could even be 3 equations, but for us, we focus on 2 equations. So systems just means 2 equations. And what we are looking for is their solution, meaning where are they equal? Where are they the same? And there's 3 different types of solutions you're going to see. And we're going to talk about them now. So the first type of solution is the one solution. So if you think back to Friday, where we had those students with 2 characteristics, and we were trying to see where they were sitting, that was our one solution example. So a one solution is where we have 2 lines that come together and intersect or cross at one point. So think back to our students when they had 2 characteristics and we were trying to see where they sit. We were looking for that spot where they both were the same, where they crossed. So we call that an intersection, but we'll get into that in a little bit. So one solution, you're going to see 2 lines that intersect. The next section here, the no solution, is where we have these 2 lines that never cross. They're side by side, right next to each other, but they will never come together and cross. So think about this as that one student at the end where we said, can you have a student be quiet and talkative? So yes, I know some of you were saying yes on Zoom, that's possible, but let's think about it in a traditional classroom where you actually have a seating chart, okay? You can't be quiet and talkative at the same time. And for those students, there was no seat in the seating chart. They were either sitting outside or they're just non-existent. So a no solution would mean we have no lines that come together across. Okay, the next type of solution you can have is the infinitely many solutions. Infinitely means we go on forever, it never stops. We have so many of them. And that looks like, here we go. There we go. It looks like a single line. So think about this as the students that only had 1 characteristic and they had as many seating options as that line extended on the coordinate plane. That's the same case for the infinitely many solutions. They could sit anywhere along this line, so they had many choices. Okay, let's go on over to your class kick notes. Let's drag those pieces over. The one solution was where we had the 2 lines crossing each other. The no solution is where we have 2 lines side by side where they don't cross. And the infinitely many solutions is where we have a single line like that. So just 3 pieces that you're dragging over for now. Those are the different types of solutions. So again, when you see these graphs, they're all straight lines. So for this new unit of system of equations, we're looking at equations that are linear equations. So the y equals mx plus b form. Okay, going back to your presentation. We're going to talk about a little bit more about these different types of solutions and some vocabulary words that you're going to see here. So when we have a one solution, we have a one solution when the 2 lines intersect at one point. So from now on, you're going to hear us say that word a lot: intersection, point of intersection, or intersect. And that's just saying where the 2 lines cross, where they connect at that point. So when we have a one solution, we call it, we say that the 2 lines intersect, and they intersect at one point. So when we have an intersection of 1 point, okay, we get a solution for x and y. Oh, good question. At some point, will there be exponential graphs like this, or is that not possible? Yes, you can actually have different types of equations on the same graph, and we can still be looking for where they cross. But that's for later math years. So I think you'll see, well, maybe you will see them, but you can see them in Math 2 with different types of equations, or in Math 3. Just depends. Yeah, you can. Okay, so when we say they have a point of intersection, we find a solution and we get an actual number for X and an actual number for Y. But here are some clues that help you decide whether or not these equations will have a solution or not. So when you have equations, there are some clues you're going to want to look at. And let's use these two as an example. Y equals 3x minus 4 and y equals 4x minus 2. Okay, we have two linear equations, but when we look at their slopes, they're different. The first equation has a slope of 3. The second equation has a slope of 4. These slopes are different. And when we have equations that have different slopes, we know that there has to be one solution. So it's a little clue that you can look for before you even start to graph them. Or even after you graph them, you can go back and ask yourself, should this be a one solution? Oh, okay, these have different slopes, so yes. So it's another way of checking your answers. But when you have two equations that have different slopes, we know we're going to have one solution. All right, moving on to the no solution. When we have no solutions, and you guys saw those two lines right next to each other, we call those two lines parallel lines. So you might have heard this in 8th grade. You do look at parallel lines more in geometry, but when we have two lines that are right next to each other that never come together across or intersect, we call them parallel. And parallel lines will just never intersect. So a clue to look for in your equations is the slope again. So let's look at this equation. We have y equals 2x minus 4 and y equals 2x plus 3. When you pay attention to the slopes, we have a 2 here and a 2 here. Both equations have the same slope. So that is a big, big clue for no solution. When you have parallel lines, they're coming from the same slope. So parallel lines are two equations that have the same slope. All right, what happens when we have infinitely many solutions? Well, that just means we have two lines that are the exact same line. They might look different when you have equations, but when we start to graph them, okay, it'll look like you only have one line. But really what that means is you graphed your first line, and when you go to graph your second line, it's the exact same one on top of that one. So how do we see, what kind of clue can we use to figure that out? Here are two equations again. 2x plus 4y equals 8. The second equation is x plus 2y equals 4. These are actually the exact same equation, but they look a little different right now. So when you take that first equation and divide it by 2, you're going to get the exact same equation as the second one. And I'll show you what I mean by that. So if I go in here and divide every single piece by 2, I get to simplify it, and I do 2 divided by 2. Well, that's just 1. So that just gives me x. Moving on to the next term here, 4 divided by 2, that's just 2y. And the last piece over here, 8 divided by 2, well, that just becomes 4. So by dividing by 2 every single term here, I get x plus 2y equals 4, which is the exact same equation as the one in the bottom. So when you have two equations that are actually the same, that's where we get the infinitely many solutions. So these will help you out a lot just by looking at the slopes and determining a solution, especially if you have like a multiple choice test and it's just saying, is this a one solution, no solution, or infinitely many solutions? You might not even have to do work if you just take a look at the steps. Okay.
Yeah, so it's totally like learn those tricks because it'll make life so much easier.
Okay, so going back to your class kick notes, we're going to go ahead and no wonder it looked weird. I didn't even put them in the right spot. Okay, boys and girls, I put your graphs in the wrong spot. You want to grab these and take them up one section. There we go. As I was going back to the presentation notes, I saw, wait, why is that middle spot taken? Okay, your graphs should be at the very top, replacing the other graphs. And this middle point here is to describe that the two lines intersect at one point for one solution. So remember, that is one of our vocabulary words, intersect, means they cross. Our clue to look for that is where they have different slopes. Both equations do not have the same slope. They are not identical equations. Our one solution is where we have parallel lines. So some other vocabulary words, parallel lines just means right next to each other. They don't cross, they never intersect. The clue that lets us know they're going to be parallel is the fact that they have the same slope. When we look at the equation, we see the same slope. Infinitely many solutions means we have two lines that are the exact same when graphed, and the clue to look for is having the same equation. Same equation. Okay, I'll zoom out here. There we go. If you're not able to follow along with this and you want to take a screenshot of slide 2, go ahead and do so now. Slide 2 is completed. You're just getting some vocabulary words here. And we're talking about the different solutions we have. Remember, one solution, the lines intersect. A little clue is to look at these slopes. They are not the same, they're different. So that'll be one solution. No solution is where we have two lines next to each other, which means they're parallel. And when you look at the slopes, they are the same. Infinitely many, just one single line, same equation. Okay, give me a thumbs up if you're ready to move on to the next slide. Give me a clap if you need more time. All right, here we go. So we're moving on to the next one. So on the next slide, we actually get to see what a solution to a system of equation is. How do we find the solution to a system of equation? Okay. So after today's lesson, you should be able to say, I can solve a system of equations by graphing. How do we solve a systems of equations by graphing? Well, all you have to do is graph the lines, which is just practice from your bell work. This is why we keep practicing these skills that you've learned in the past, because they don't go away. We keep working with them. So we're going to graph the linear equation, but we're going to graph two of them on the same graph. And what we are looking for is the point of intersection. So see that word, point of intersection. That's just where the lines cross. And what that gives us is the solution. So let's go back over here. We can go ahead and drag those little pieces over. I can solve a system of equations by graphing. And how are we going to do that? We're going to graph the lines on the same graph. So graph the linear equations on the same graph, and we're looking for the solution. And that is at the point of intersection. So just two pieces for this time. Okay, so let's practice. Okay, you have two equations here. And the question is asking you to solve the system of equations by graphing. We have y equals 3x minus 4 is our first equation. And our second equation is y equals negative 1 over 2x plus 3. Now, before I actually get started in graphing these equations are already in a nice form that we can graph them, but you're not always going to get equations in this form. So we are going to have to spend some time getting them in slope-intercept form. If you forgot what slope-intercept form, it's just our form which we know y equals mx plus b. When you have this form, it's very easy to graph, just like you saw in your bell work for question number 1. Well, both of these equations are in that form, y equals mx plus b, so they're just ready to graph. So we start with your y-intercept, and I'm gonna ask you to help me out with this first graph here, with this first equation. What is our y-intercept there?
-4.
Yes, perfect. So we start at the middle here at the center and we go down 4. 1, 2, 3, 4. That's your y-intercept. The next thing is to use your slope. What is the slope in this equation?
3.
Yes, good. So we could say 3, or since we need a fraction, we could say 3 over 1. Okay, so this slope is a positive 3, which tells us to go up, or a positive 1, which tells us to go to the right. So up 3, over to the right. So I'm going 1, 2, 3 up and 1 to the right. Oh no. Pin 1, 2, 3, 4.
It says no.
1, 2, 3. 1, 2, 3 over 1. Okay, you want to make sure you put as many points as you can on these coordinate planes. Get your lines as long as possible, because we are now trying to see where two lines come together and intersect. If your lines aren't long enough, you're going to think they don't intersect. So make sure you're using your slope as many times as you can to get as many points on there. All right, our next equation says y equals negative 1/2 x plus 3. What is the y-intercept in the second equation here? Yeah, perfect. So we go to the center and go up 3, 1, 2, 3. And put that point there. Our slope is saying to go down 1 and over 2. That's this one right here. That's your slope. So we can write it as down 1 over positive 2, or you can write it as positive 1 over negative 2. We're just doing the complete opposite. Notice how this was a negative, turned it into a positive. This was positive, turned it into a negative. So the first slope says to go down 1 over 2. Look at what just happened now. When I went down 1 and over 2, I'm starting to see that these two lines are sharing this point. Going down 1 over 2 again. I don't have enough points up here, so I can go up 1 and over 2 there. This graph shows us two lines that are intersecting. And if we would have used our clue to look at the slopes, this is a 3 and that is a negative 1 over 2. The slopes are different. And because they're different, we should know that there's one solution. So we're interested in knowing where do they cross, and they intersect at the point 2, 2. If you don't know where I got that, okay, oops, it shifted here. So in our graph, all we have to do is count to get our x coordinate. So we go 1, 2 to the right, and then we go up 2 to get to this point of intersection. So this is a one solution at 2, 2. And our clue would have told us that by looking at the different slopes. Okay, we're going to go ahead and drag those pieces over. when we look at these two equations, they intersect, they're crossing, and they intersect at 2, 2, which tells us that is one solution. Okay, we're moving on. We're solving another system of equations. You have another two different linear equations here. Y equals 2x plus 1, y equals 2x minus 2. In this example, we're going to start by looking at the slope first to see if we can determine if this is one solution, no solution, or infinitely many. So what is the slope of the first equation right here? Say that again?
2.
Yes, 2. So our first equation has a slope of 2. Let's look at the second equation. What is the slope of the second equation?
2.
2. Very good. So we see that both of these lines have the exact same slope. So think about what we talked about in the other slide. When you have the same slope, give me a thumbs up if that's one solution. Give me a clap if that's no solution, and give me a different reaction for infinitely many. So thumbs up if you think this is one solution. Clap if you think this is no solution. Or a different reaction if you think this is infinitely many. So some of us not quite sure. Okay, well, let's take a look. That's why we graph them, if you can't tell. Okay, when we graph these equations, remember we want them in y equals mx plus b form. Luckily, these two are in mx plus b form. So you just start by graphing your y-intercept. In this case, it's plus 1. Start at the center, go up 1. The slope is a positive 2, but you can turn that into a fraction by putting it over 1. So that just says to go up 2 over 1, up 2 over 1. Notice if I just leave them this way, my line is really short. And I don't get to see if it's long enough to cross with another line. So I can use the opposite slope to put some more points on here. So if this was a positive 2 over positive 1, I can use negative 2 over negative 1. See, the complete opposite. I'll go down 2, 1 to the left, down 2, 1 to the left, down 2, 1 to the left. That gives me a really long line. Ooh, that's so straight. I'm really proud of this line.
Every period, you keep getting better and better.
I know.
I'm pretty sure I would have done the opposite and gotten worse and worse.
Okay, that's your first line. Let's take a look at what happens when we actually put the second equation on this graph. Start at your y-intercept, negative 2. So I go to the center, and that means I go down 2. Next thing, look at your slope. A 2 by itself means it's a 2 over 1. I can turn it into a fraction by just putting the 1 under it. That means I go up 2 over 1, up 2 over 1, up 2 over 1. But it's possible that they might cross down here, which means you want to use the opposite slope, negative 2 over negative 1, to put some more points in the bottom. So I can go down 2 and 1 to the left. I'm nervous. Okay, let's see if I can do this. Oh, that's okay. It's not the best.
I was like cheering you on and didn't realize that I was muted, which probably was a good thing because I might have like made you nervous.
Yeah, that's true. I would have gone. Okay, so those of you that saw the same slope and gave me a thumbs up, or a clap. No, you gave me a clap. If you gave me a clap and said no solution, this is correct. They're parallel lines, which means they never intersect. They're right next to each other. So we say no solution. This is a little off from mine, but only because there's a new graph on top of that. Okay, so let's go to your Classkick notes. Let's drag those pieces over. Okay, no solution for this one because they were both parallel lines. They had the same slope, which tells us no solution. All right, for the next section, we have two new equations, y equals 2x plus 1 and 2y equals 4x plus 2. If we're going to solve the system of equations by graphing, then we need to make sure our equations are in the slope-intercept form, y equals mx plus b. The first equation is in y equals mx plus b form, the slope-intercept form. So this one's okay to go ahead and graph, and we can do that now. Okay, pretty much the same as the other equation. So your slope-intercept is a +1. We start at the center, go up 1. Your slope is 2/1, which means we go up 2, 1 to the left, up 2, 1 to the left. We can use the opposite of that, -2 over -1, to put some more points on the other side, down 2, 1 to the left, down 2, 1 to the left. Okay, that gives us the first line here. The second equation is the one that's going to give you some trouble here. It's not in the y equals mx plus b form, but it's really close. So we are almost there. This is where the second problem for your bell work comes in handy. Think about when we were solving for x, we had to do some things to leave it by itself, to isolate it. That's exactly what we're doing here. But in this case, we want y by itself. Why do we want y by itself? Because this equation here has y all by itself there, the slope-intercept form. So take a look at 2y equals 4x plus 2. We need to get rid of that 2 in the front of y. Well, between 2 and y, there's multiplication there. We have to do the opposite, which in this case is to divide by 2 in each of those parts of the equation. So if you divide by 2, 2 divided by 2 is just y. 4 divided by 2 is 2x. And 2 divided by 2 is just 1. So we get the equation y equals 2x plus 1. So we went from having 2y equals 4x plus 2 to having the exact same equation y equals 2x plus 1. That is the exact same equation as the one on the top. If we go on here to graph them, we get the exact same line on top of each other. So when you have both equations that are identical, you're going to have the same line, and we say we have infinitely many solutions. Okay, so let's go back to your Classkick notes and take those 3 pieces over. In this case, we had to divide by 2 on this equation. We see that both equations are identical, so they are going to be the exact same line. So this is infinitely many solutions. Yeah. So remember, when we graph these equations, we can graph them when they are in slope-intercept form, y equals mx plus b. This first equation was not in y equals mx plus b, the slope-intercept form. So we need to do some work to get it in slope-intercept form, y equals mx plus b. So that's why we divided by 2 on both sides. When we divide it by 2, we get the exact same equation here as the one we had on the top here. So that's why they're the same. And they're the exact same line and we only have one on there. Very good question. Anybody else have any questions here? We're going to keep practicing, so don't worry. And honestly, for this week, we are just practicing graphing up until Friday. Why? Because some of you guys need the extra help on graphing. And it just prepares you even better to work with two equations. Okay. Give me a thumbs up if you're good to move on to the next slide. Give me a clap if you need more time. Okay, so go ahead and click over. So we have a lot of graphs here and we don't have much time left. So what we're going to do today is we're just going to work through the first one up here. I will show you the example in the presentation and then you'll come in here and make the graph yourself. Because again, we want you to practice your graphing skills. We want you to practice putting two lines on the same graph and finding where they intersect. So we're going to end it after this one, and then I'll explain your homework, and you guys will be free to go. Okay. Okay, so we have here a question that is asking us to graph to find the solution of the linear system. So it means you have two equations, you need to graph them and find where they intersect. Now, when we graph them, remember, it's only going to be helpful, or we will be able to graph them easily if we have the slope-intercept form, y equals mx plus b. So when you look at that first equation, x minus y, let me write it down here. So when we look at x minus y equals 5, give me a thumbs up if that is in slope-intercept form, meaning this one, y equals mx plus b. Give me a clap if it's not in slope-intercept form. Good. Yeah, this is not in y equals mx plus b form. So we need to do something to this equation to start getting it in that form. So notice on the left side, we now have an x. But when we look at slope-intercept form, there's no x here. It's on the right side. So we are going to move this x to the right side. And we do that by solving an equation, which means we need to do the opposite. So I'm going to split it up. That t here splits it up in two sides, the left side and the right side on by the middle here in the equal sign. And we do the opposite. So if we have a positive x, what is the opposite of adding an x?
Subtracting an x.
There you go. So what we have to do is subtract x. And when we subtract the x on the left side, you have to subtract it on the right side as well. Now you have 1x and you're taking away 1x, which gives us 0. And that leaves the minus y all by itself. On the right side, we have 5 minus x, or negative x and the positive 5. Okay, you cannot combine these. They are not like terms. So you want to think of combined like terms, but in this case, this is a whole number and this is a variable that we can't do anything with them. So we just leave them as it is. So I'll write minus x plus 5. Why did I put the minus x there? Because if you look at the form, the x is in the front and then the number is in the back. How did I know this was plus 5? Because this 5 is a positive. So we get the equation negative y equals negative x plus 5. When you see this equation here, you're not done yet. This equation, the slope-intercept form, does not have a negative y. So we need to get rid of that negative y. And the one way we do that is by dividing by a negative 1. So if I divide by a -1 here, I have to divide by a -1 in each of these sections. So the reason why we do that is because a negative divided by a negative is just a +1. So we get y all by itself. On the right side, we have a -x divided by a -1. Anybody that can tell me what that is? A -1x divided by a -1.
Positive X.
Yes, very good. It's just a +x. What about this side over here? The +5 divided by a -1.
-5.
There you go. So we get x minus 5. And you now have an equation in slope intercept form, y equals mx plus b, and we can actually go in here and graph it. So we graph it by figuring out what the slope is and what the y-intercept is. So take a look at this equation. Anybody that can tell me what the slope is? Y equals x minus 5. Think of what is actually in front of this x.
1.
Yeah, good job. So our slope is equal to 1. Remember, it helps us if we write our slope as a fraction, so we can say m equals +1 over +1. But because we want to put as many points on this graph as possible, we can also use the opposite slope. What's the opposite of a +1? Anybody?
-1.
-1.
Yeah, good. So we can say -1 over -1. You have two options for your slope. This is going to help you put as many points as possible. So we looked at the slope. The next thing you want to do is find the y-intercept. Take a good look at this equation, y equals x minus 5. What is our y-intercept?
-5.
Yeah, good. Our y-intercept is -5. And you're ready to graph this equation here by going to the -5 on your y-axis and using your slope to go up 1 over 1, up 1, 1 to the left, 1 to the right, up 1, 1 to the right. And we can use the opposite slope, -1, so down 1 and 1 to the left to put some more points on here. And just connect them. So if you go over to your class kick notes, I want you guys to go ahead and graph that line right now. Graph your y-intercept, then use your slope to get more points on there and connect it. And then we'll come back and graph the second equation. So I'll give you guys 1 minute. Go ahead and graph that line just like I did over here, and I'll keep this one up. So it's the exact same, but in your class kick notes. So graph this line. All right. Yep, good. I see some of you having the correct line on there. Oh, some of you already finished. Okay, good. Okay, I'll do this really quickly. We need to have 1, 2, 3, 4, 5. I need to zoom in. I can't see. 1, 2, 3, 4, 5. Up 1 over 1, up 1 over 1 on this side. Remember, go to the add line option to connect all of those dots. We want to make this as long as possible. So I'm going beyond those points and making it really long. It's going to help us see the point of intersection. Okay, That's only one equation. We need to graph the other equation. So let's look at 2x plus 3y. That is not in slope-intercept form. Y equals mx plus b. So a couple more steps, but that's okay. This x needs to be on the right side. So you want to do the opposite of positive 2x. That is going to be to subtract 2x on both sides. 2x minus 2x goes away, that's 0. And we get a 3y on the left side. On the right side, 0 taking away 2x, well, that's just negative 2x. And there's that plus 0, the invisible 0 in the back, but we don't need it in the back because adding 0 means you are not adding anything. Okay, we're almost there. Remember, y has to be all by itself. Right now we have that 3 in front of it. So to get rid of the 3 in the front, we divide everything by 3. 3 divided by 3 is 1. That leaves us with y, and we get negative 2 over 3x. At this point, before we graph it, we can see if this is no solution, one solution, or infinitely many solutions. This is, the slope was 1 here. Our slope here is negative 2 over 3. These are different slopes. When they are different slopes, we should have one solution. So your slope here could be plus 2 over negative 3, or we can use negative 2 over positive 3. Notice how I gave the negative to only one number. When you have a negative in the front, it's not both numbers that are negative, it's one of them. In the first one, I made the 3 the negative, and in the second slope, I made the 2 the negative. It helps to have both. Okay, and the y-intercept, remember, is that invisible 0 in the back. So start by putting your y-intercept. That goes at 0. If we use the slope, oh, here we go. If we use the slope of going up 2 and 3 to the left, I am here. So 1, 2, up 2, negative 3 means 3 to the left, 1, 2, 3. Repeat that, up 2, negative 3 means 3 to the left, 1, 2, 3. And one more time, up 2, 1, 2, 3. If I use that slope, I don't get to see if these lines cross or not, which is why we need to use the opposite slope to put more points on this side. So the opposite slope says to go down 2 and 3 to the right. So down 2, 3 to the right, that puts me here. Down 2, 3 to the right, that puts me there. Down 2, 3 to the right, puts me there. Connect those points, and you see this point here is the point of intersection. So these two lines intersect at 3, negative 2. If you're not sure where I got that, maybe I moved too fast, you need to find the x coordinate and the y coordinate. So to do that, you start at the center and you move left or right. In this case, I'm moving right. 1, 2, 3. That 3 here. And to get to that point, I go down to 1, 2. So our solution to this system of equations is 3, negative 2. So that is the solution, the point of intersection. So I'm going to have you guys finish up your second line here. Remember, start with the y-intercept, which was 0. Our slope set to go up 2 and 3 to the left. 1, 2, 3. Up 2, 3 to the left. Up 2, 3 to the left. We can use the second slope here to give us more points. So we go down 2 and 3 to the left, down 2 and 3 to the left. Go ahead and connect those lines. What we are looking for is, do they cross or intersect? Yes, right here. And your answer should be written as a point, negative 3. Why do I always write negative 3? It should be positive 3, -2. Okay. So it might have been a little fast today. It's just because we went through a lot of examples, but we will have some time tomorrow for you guys to practice graphing on your own and finding the point of intersection or the solution if they do intersect. But that is it for your notes for today. I'm going to go ahead and talk about your homework assignment. So really quickly, to find your today's homework assignment, you go to week 8. Right above your week 8 notebook, there's that solving systems by graphing. You want to click on that. It's going to be a Classkick worksheet. Make sure you log in. I'm just typing in the name so I don't mess up the teacher account. And this is all you have. You have 6 questions. And what you are going to do is graph the system of equations. So solve the system of equations below. Find which mole is at the intersection of the 2 lines given. Use the add line. So go on here. Well, first you'll want to draw some points, and then you'll want to use the add line to connect your points and find where they intersect. I gave you easy equations. Well, not that they're easy, but I didn't have you work through the harder ones where you have to leave y by itself. They're already in y equals mx plus b form, in slope-intercept form. So all you have to do is go in there and graph them and find out what section, at what point do they intersect. So they're going to cross at one of these moles, or maybe not. We'll see. But if they intersect here, that means this mole here is the solution. You just find the point, the location of that mole, or they could intersect here, or they might intersect here. So you're just finding out what mole do they intersect. If you get parallel lines, then you say no solution. If you get one line, then you say infinitely many solutions. But that's it for your homework. You get 6 of them, and they're all in y equals mx plus b. I'm going to go back to your Classkick notebook really quickly and let you take a screenshot of that. I'll zoom in since we're looking for your graph here. And while you're taking a screenshot of that, do you need screenshots of all of the slides or just this one? Do we need all of them? Okay, I'll go back. Do you need to finish the rest? No. Or Dr. Brown, would you like them to finish the rest?
No.
Okay, that's
You
what I
don't
thought.
have to. Yeah, we'll do
So-
those tomorrow. But I will stop recording at this point because